The second comparing groups technique we want to introduce is the independent sample t-test. Independent sample means that our samples, each of the observations are independent from each other. There's no influence whatsoever between our samples. So that's why we call it independent sample t-test. So you need to bear in mind, basically, there are different types of t-tests. There are other types of t-tests that assumes, for example, the samples are actually influencing each other. They could be paired, for example. But independent sample t-tests are the most commonly used ones, and we will introduce this in this module. So what's the difference then between a t-test and the previous chi-square test? We touched on this already when we have a general introduction of the comparing groups techniques, but I want to emphasize again here that the difference between a t-test and a chi-square test is mainly on the nature of the dependent variable. Okay, so for chi-square test, the dependent variable is categorical. For t-test, the dependent variable is continuous. This is very important because if you use t-test on categorical dependent variable, then it will treat that category as continuous. Then that you is the wrong answer. Okay. And of course, if you use chi-square test with a continuous dependent variable, then again that give you a biased or a inaccurate answer. So it's very important to realize that now we are dealing with a continuous dependent variable. And because we're dealing with a continuous dependent variable, it's the first time we need to worry about the distribution, the 5 assumptions, whether the 5 assumptions has been fulfilled. Because chi-square test by itself is actually a non-parametric test. However, the t-test, it could be parametric, it could be non-parametric. If it's parametric, it's t-test. If it's non-parametric, it's MWU test. All right. So what does this imply? It implies that before we could run any t-test, we need to actually examine the distribution of our dependent variable. So for example, in this case, a self-esteem score, comparing male and female against self-esteem. So the research question is simple. We're saying that between male and female, there is a difference in terms of self-esteem. It could be that male are more, thinking higher of themselves. It could be females are more optimism of themselves. It could be anything. The main point is that there is a gender difference in terms of self-esteem score. So to make sure that we carry out the right test, we need to examine whether we should go ahead with independent sample t-test or MWU test. To do that, the first thing we need to do is to actually examine the self-esteem distribution. Okay. After that, if it's a normal distribution, we could carry on using the independent sample t-test. If it's not, then we need to carry on using MWU test. Okay, so let's do it together. Again, I have the detailed steps here, but instead of walk you through the steps, we'll do it together. So we come back to the long data set the complete data set, we've got 35ED, and I test exactly the gender's influence or gender's difference in terms of self-esteem. How to do that? Okay, for the t-test, we go to analyze. Oh, hang on. We need to check the distribution. So we go to graphs, legacy diagrams. You could build your chart, no problem, but I use histogram command already. And we're testing against the dependent variable that is the self-esteem. So I just move self-esteem to the variable box, and no need to worry about anything else. Okay, so very interesting. You can see that total self-esteem, it's not a normal distribution. It's actually missing the entire right-hand side of that bell shape. So now you know that instead of independent sample t-test, you need to carry out MWU test. Okay, but I demonstrate both. I'll demonstrate how to do it both ways. But for this dependent variable, you should have carried out MWU test. However, let's assume that we have a bell-shaped distribution. Then how to carry out a t-test, an independent sample t-test? We go to analyze, we go to compare means, then we go to independent sample t-test. Okay, you can see that there are other types of t-tests. There are summary, paired sample t-test, but we're using independent sample t-test. Now we have the test variables and grouping variables. Remember when we use chi-square test, we have the rows and columns. Now they're calling it something different again. It is what it is. It's just how SPSS works. So here the test variables are dependent variables. So test variables in this case is the self-esteem. The grouping variables are actually the independent variables. So we're going to use gender as grouping variables. As soon as you put gender into the right-hand side box, grouping variables, you notice that there are two question marks. Why is there two question marks? If you just ignore it, you won't be able to run. See, I can't even click on that OK button. It's because this is one way that SPS reminds you only two categorical groups allowed for t-test. Otherwise, it's an ANOVA test. Okay, so what you need to do is actually define your groups. Define your groups means how you've indicated your groups, whether it's by 1 and 2 or 2 and 3 or 1 and 0. So just click on define groups and tell SPSS, I got two groups, I name them 1 and 2, and that's it. Okay, and you don't need to change anything else, just click OK. And this is the result of your independent sample t-test. But as I said, this is not normal distribution. We should have run a cross-call values, a MWU test. So we'll do that later. Now let's assume that it's normal distribution and let's examine the t-test result. The first table here is the descriptives, mean value standard deviation of both self-esteem on both male and female side. The important thing is to look for the p-value, of course. So the p-value here, the significance level here is reported here with the sig dot two-tailed. So it's actually this one, this number, 0.105. You notice that there's another sig reported here, and that is actually Levin's test. Levin's test is a test for heteroscedasticity that SPSS has automatically thrown in for you. So in this case, it's not significant, which is good news because we don't want this to be significant. If it is significant, then we have a problem of heteroscedasticity. Okay, but as I said, if you have a decent size sample, you don't need to worry too much about it. So it's this one, sig with two-tail, that is important. What can we do about it? We use this number to compare against our alpha or our cutoff point in terms of p-value, that is 0.05. This is larger than that. So again, the null hypothesis will be accepted. The hypothesis of a difference will be rejected. That is our test indicating that there's no gender difference in terms of self-esteem scores. But as I said, the distribution looked like this. You should not have run a independent sample t-test. We should actually run a MWU test. So let's run a MWU test together. MWU test procedure is not actually in the curriculum of this module, but it's very similar. It's just located in a different menu, and you will see, uh, you know, again, it's a quick and efficient way of testing non-normal distribution uh, comparison of means. So where can we find MWU? Go to Analyze and go to the non-parametric test, and go to legacy diagram dialogues where they have already made things. So it's not chi-square. What we need is something called a two independent samples non-parametric test. Just click on that. And again, the test variable and grouping variable is the same way that appears in independent sample test. The test variable is the dependent variable. So in this case, it's the self-esteem. Grouping variable is gender. So you can see that you define the groups again. By default, it's MWU test, so I don't need to change anything about it. I am not using any other types of non-parametric pairwise, non-parametric two independent sample test. So just click OK. Now, what we've got is this one and this one, okay? And this time, instead of looking at for a p-value, we're looking at a significant, it's still the p-value, but instead of looking at a sig level, we're looking at something called a asymptotic significant two-tailed. And again, we use this number to compare against 0.05. It's actually a Z test, but you don't need to worry too much about it. For this one, it's the mean ranking, so it's actually not comparing means. It compares the mean rank because it's non-parametric. But again, you don't need to worry too much about it. So MWU test told us that there's no significance. We should again reject the hypothesis one, that is, there is a difference between self-esteem among different genders.